So what happens to this energy as it comes into the atmosphere? That's what we're wanting to take a look at. We've talked about some of what's happening or how they're being stopped, but I want to talk about what the result is as that happens. So our gamma rays and X-rays, they're coming in and they hit the ozonosphere. Very, very strong rays. They're absorbed in the ionosphere. The ultraviolet rays are going to be coming in. And when they hit the ozone layer or the ozonosphere, then most all of them get stopped. There's a few that are able to make it all the way through. And so we're wearing our sunscreen. And we also know that our light energy is going to be coming in. Red, orange, yellow, green, blue, purple. Goes through the ionosphere, through the ozonosphere, comes all the way down, and when it hits the surface, it's either absorbed or reflected. If it's reflected, then that's light energy that goes right back off as shortwave energy, or based on the surface albedo, it might get absorbed and then re-radiated out as heat energy. Long wave heat radiation. Perfect. Okay, now we got a problem here. It goes back to our friend Einstein. Energy cannot be created or destroyed, but I'm talking about the energy stopping there at the ozonosphere. Energy cannot be created. I talk about the ozonosphere. Now, you might remember way back when we were talking about the electromagnetic spectrum, I was talking about microwaves and water and how water absorbs. But what happens to that water is it starts to shake. When the ozone, you might remember in another video, I was talking about that ozone layer. And when the ozone gets hit, it absorbs that ultraviolet energy and it starts to shake a lot. So what we are seeing in both of these is an increase in kinetic energy. Now, in a previous video as well, we talked about how an increase in kinetic energy means that the temperature is increasing. So with both of these, it absorbs but increase kinetic energy. This guy as well absorbs, but makes it warmer. Right? And so here's what's happening. That light energy does make it all the way down to the surface, right? And either it's going to reflect as light or it's going to be heating. So here's what we want to look at now. We want to kind of figure out what happens to the temperature profile. What's the temperature profile as we go up through the atmosphere? Now, these most certainly are not drawn to scale, but as you start down here in our lower atmosphere or down here at the surface, the higher you go up, it's going to be getting cooler and cooler and cooler. Now, we call this region right in here where the temperature starts to get cooler and cooler, right down here where we are. Like, I'm going to draw myself, and I look like a tiny little trophy standing there. I call it the trophosphere. No, it's the troposphere. Okay. Now, as I start to go up through the ozone layer, well, the ultraviolet energy is coming down from above, coming down from the sun, hits the top of the ozone layer. These guys are going to be absorbing more energy than these guys are down here. So as I go higher and higher through this particular layer, the temperature starts to get warmer, warmer, warmer. Right? We call it the ozonosphere when we are looking at the function. But for the temperature, when we're talking about the temperature, we call this the stratosphere. Okay, there is this region between the ozonosphere and the ionosphere where nothing's really happening. Okay? And as you go up through that layer, the temperature then starts to get colder again. It's in the middle between these two guys, so we call it the middle sphere, except we use a funky term. It's called the like Mesoamerica, right? The mesosphere, or the middle one, right? Where nothing is happening. All right, now, as we go up through this ionosphere, the ionosphere is grabbing these crazy guys, and the temperature is going berserko. This layer gets extraordinarily hot. It gets very, very hot, so hot that we call it the hot layer. No, we name it after a thermos. No, wait, no. We just call it the thermosphere. Okay, now, is the ionosphere and the thermosphere in the same spot? Yes, the ionosphere is based on the function. We'd say that it's the ionosphere. For temperature, we'd say it's the thermosphere. For the function, we would say it's the ozonosphere or the ozone layer. And for the temperature profile, we call it the stratosphere. Okay. So as we get up off of the surface where the heat is radiating, the temperature is going to be getting colder through the troposphere. As we go up through that ozone layer, we call it the stratosphere. When we're looking at temperature, it gets warmer. The mesosphere, nothing's happening. So it gets colder, and then the thermosphere goes crazy high, crazy, crazy hot. This is not drawn to scale. Right? If it were drawn to scale, it would look something like this, right? Here would be the surface, and it would be like, okay, well, it's here, it's getting colder, and that's going to be our troposphere, and then, a little bit warmer in the stratosphere, and then a little bit warmer in the, or cooler in the mesosphere, and then boom, right? So that ionosphere takes up a ton of the atmosphere. So for each one of these little layers, and these first three guys, but if we drew it like that, then we wouldn't be able to see anything. Okay, the only other thing that I want to throw in for this, for some reason, as we're looking at our temperature, is at the end of each layer, we have a name for like the boundaries between each spot. Okay? And so for these guys, we're going to be going up through the troposphere, and just like on your phone when you want the music to stop, you hit the pause button. Well, this line right here between the troposphere and the stratosphere is called the tropopause. Okay? The stratosphere, you get to the top of the stratosphere, and that is the stratopause. You get to the end of the mesosphere, and it is the mesopause. And then you get way outside to the furthest outside part of our atmosphere, which is way out there. That would be the thermopause. Way out there. Okay, so what we have is we're going to have our function of our atmosphere closely tied to our temperature profile. When we're talking about temperature, we're talking about the speed at which the molecules are moving around. Okay, so when we say the temperature is very high, if we were out there, the air is going to be very, very thin, right? But the molecules are zooming around very, very fast. Same thing in the ozonosphere with the ozone layer. The ozone absorbs that, and it's going to be flying around like crazy as well. So that's going to be our temperature profile.